Now we have the international part of our annual convention here. Hearty welcome to the session Transformation of the Energy Infrastructure, International Perspective and Impulses. As you may know that I'm from Bavaria, but I work for the federal state of Hesse, and I met some more compatriots from Bavaria. So I invited all of them to take part in this international session because the State Secretary was a bit hesitant in his speech when he was talking about Bavaria. But I think it's a good idea to have a kind of competition between the federal states in our German Republic, because this stimulates the performance. And at the end, we have to fix a problem where cooperation is key. We have exactly 1 hour, and we want to talk about some technologies which could, or at least which have the potential to mitigate climate change. But first I would like to make a few introductory remarks. Let me start with the statement that climate change is a global challenge, and of course this needs a global answer. Whatever I do locally has to be seen in a global context. So in a nutshell, I have to act locally, but I have to think globally. And this global cooperation is a real challenge because it needs common values, it needs common goals and international cooperation. And when I reflect a bit on the President of the United States of America, I have a few question marks whether this is helpful when it comes to common values, common goals and international cooperation. Because again, this will not change. We have a global challenge. Of course, cooperation needs mutual trust, appreciation and common responsibility for the planet. And learning from each other is very supportive, and it creates effective and efficient solutions. And of course, what I said before, it makes no sense just to develop a solution for my own environment. I need solutions that also support the others. And of course, this strengthens the German market. And last but not least, we also have to think about financial flows, because all the investments have to be financed, and you can continue. The stable framework is another precondition. The State Secretary mentioned it clearly. So we need a stable framework in order to attract the financial flows, and of course we need the technical solutions. We have now 4 companies who are active or which are active all over the planet. We have Danfoss, we have Vulcan Energy, we have TÜV Süd, and specifically the affiliated company Evity, and we have Bloom Energy. The pitches we will hear, I have to look up, I think it was 10 minutes, or was it 5? 5, okay, so I have to be more strict. 5 minutes. We will hear something about the transformation of heating and cooling systems. We will hear something about the simultaneous provision of lithium, heat and electricity. I already mentioned that I think this combined generation of values is a very, very promising approach. TÜV Süd is, of course, very well known about certifications in the energy sector, but Evity in this case will focus on hydrogen, And Bloom Energy is a vendor of fuel cells and electrolyzers. We will have the 4 pitches, and then we will have a round of discussion so that we can go a bit more into detail. And then, of course, we open the floor also to the audience, and we can also pick some questions or remarks or comments from your side. I would say that's it in a nutshell. And we are starting now with Matthias Balzer from Danfoss. He is active in the field of the decarbonization of public buildings. At least this I read, and I was very astonished because we know each other since a while. But I was not aware about his specific task within Danfoss. So the floor is yours, and please start with your pitch. Thank you.
Thank you very much.
Good evening to all of you. Nice to meet you, and good to see you. So this today is not about Danfoss, it's about energy transition in Denmark. When we speak about energy transition, a lot of people, a lot of countries look at Denmark. My name is Matthias Balzer, and I work at Danfoss, and Danfoss is a Danish company. So Danfoss was founded in 1933 and is busy in the sectors of climate technology, also drive technologies, as well as hydronics and hydraulics, exactly. So when we look at Denmark, why do we look at Denmark when we speak about energy transition or heat transition? Well, it's because they're far ahead in terms of district energy. And this has several reasons, right? Just looking at the basic facts, we'll see that in Denmark at this day, we have around about 70% of all households connected to district energy solutions. This does not mean that all 70% of these households do actually use district energy. That's a little bit of a differentiation at that point, but they are at least connected. So, and the next important point is that 2/3 of that energy required for the district heating is generated by green energies and also by waste heat recovery. So those are very big assets that Denmark has been building up. And since things are picking up on an international level, Denmark has won a lot of traction in this regard. So what has actually made Denmark so successful in terms of district energy? So there were certain developments in the 70s during the oil and energy crisis that led Denmark to innovate in that sector, because they found themselves in a situation where they were completely dependent on international supply of fossil energies. And during the energy crisis, of course, supplies were short, prices were hiking, and Denmark did not feel they were able to actually handle the situation at a long term, except for paying high prices, but they did not find a solution. There was no solution in the area for that point. So actually the government, or the parliament rather, they kicked off very early by establishing a law that would require public institutions to set up a heat planning. So that was 1979, and when we look where we are today, you know, it's kind of 50 years ago, and we are still doing the same stuff that they started 50 years ago. That's of course why those are also far ahead. And I also think that they made some good decisions in actually making this product attractive for the people, making it acceptable. First of all, we've got a very good political consensus in terms of energy politics in Denmark, right? There's 2 big parties in the parliament, and they do disagree on certain topics, but not necessarily on energy or heat supply. So that makes it kind of easy. You know, you don't have to fear that every 4 years things are going to get kicked around, that certain interests are going to overweigh other interests. In energy terms, the big parties do have an alignment. I think that's a very big asset. The second one was they also thought of how they could make investment actually capable or scopable for the suppliers, and that was that they required for households to actually connect to district heating systems. And that way they could kind of found or financed the investments of the connection of the whole society, because while not everybody who is connected to the district heating energy system is actually taking district energy, they still kind of pay for the installation, the fee to the supplier. So this kind of spreads the cost among a lot of users in the whole country. And I mean, there's different point of views from individual perspectives. This might be a little bit questionable, but I think on a whole society aspect, this is a good thing, and it really helped district energy to pick off because investment was spread over many persons. So the third point I would like to point out is actually that all municipality supplies like water, energy, heating in Denmark are always non-profit. So at that point, they do compete against each other to provide the best service to the best prices, but at the end of the day, they may not make any profit. So it's a completely different system that we'll find here, obviously. And the fourth point is actually that the pricing is very close for all consumers in Denmark. So we don't have a regional difference that kind of makes a battle for energy locations. And I think these factors in total really took Denmark, gave them an advantage of 50 years. And it's not saying that everybody could just copy what Denmark did. I mean, obviously they cannot, and it's not sensible. But however, in this sense, I think that we can always look at Denmark and learn from them. And that's a lot of things are going happen. I know that Lea, the Energieinfrastruktur of Hessen, was visiting Denmark recently. Also the Danfoss headquarters in Nordborg. So, everybody's trying to pick up at that point and to really expand district energy here, because when it's done correctly, it is a cheap, reliable energy source, and it can also be fastly transformed into green energy, which is very important since you have a central kind of energy production. I would like to close with that.
The next speaker is Christian Beer from Vulcan. He's director of new businesses and exploration, and he's an engineer of geoscience, in order to find a more or less appropriate translation. So the floor is yours, and please introduce us into the activities of your company.
Thank you very much, Professor Birkner, for the introduction. Thank you all, ladies and gentlemen, for being here with us this afternoon. So I want to give you a short introduction into what Vulcan Energy does and how we kind of grow from a very small Australian German startup to now one of the biggest geothermal project developers in Germany. Vulcan is a rather young company. We were founded by one Australian and one German engineer, actually, working on the one hand side in the geothermal business and on the other hand side in hard rock mining for lithium in Australia in 2019, and went basically straight to the stock market to raise the money to develop their idea of combining deep geothermal energy, heat and electricity production with the co-production of lithium for not only the transition on our energy market and heat market, but also for the transition towards green and renewable mobility market, meaning the transitions from fossil-fueled cars to electric cars, basically. So what they found out when looking worldwide for sources of lithium to provide the raw material for the energy transition and for future mobility, they came across a certain set of geological settings, where the geology really gives us the opportunity to harvest both the geothermal energy from the subsurface and use the waters that are used as heat transport medium to get the energy out of the subsurface with certain lithium concentrations. So in this research they did, they found about a handful of spots worldwide where this coincides, where we really have specific geological conditions which heat deep below the ground that can be used and is already used in our area here, and lithium concentrations which are on a level that allow for a commercial production of lithium. So they found our area here, which basically, if we look outside in Frankfurt, the geological situation that we benefit from starts. It's the northern end of the Upper Rheingraben, or as you say in Germany, Oberrheingraben. This is a special geological setting where the continental crust basically is breaking apart, and between the mountains of the Odenwald and the Pfälzerwald, or the Vosges Mountains and the Schwarzwald in the south, we have an area where the entire geological succession is kind of shifted down to about 4 or 5 kilometers deeper than we have in the mountains. And this enables us to have reservoir rocks where hot fluids are circulating, where hot fluids are transported under geological time conditions and can be used for energy provision. So the first attempts to do that were done end of the 80s in a European research project in Sul-sur-Forêt on the French side, which led directly about 20 years later to the first commercial electricity producing geothermal power plant in Central Europe, in Sul-sur-Forêt as well. And about 3 years later and another 4 years later, the first commercial power plants in Landau in der Pfalz and Insheim der Pfalz were created, and are basically, at least for Insheim, are operating since more than 12 years without any incidents, without any problems on a commercial level. And the geologists looking into the specifics of the geothermal brine that is used for the energy transportation in both of these power plants, the temperature is about 165 degrees, which is produced there, though can be used directly for electricity or heat production, even for district heating networks, as we heard. Also contains a lot of salts. So basically the water itself is about 3 times as salty as seawater. So it has about 100 to 120 grams of salt per liter of brine. So it's a lot of salt content in there. And it also poses some technical challenges which have been dealt with in the last 25 years to keep that salt concentration under control and inject, after this thermal use of the fluid, inject all of that back into the ground. So basically the chemistry of the brine itself was not touched. But from all the projects that were drilled, and even some old oil and gas wells in the Upper Rheingraben, we knew that there's a significant lithium concentration in the brine itself. Compared to the salt concentration, it's kind of homeopathic. So we have about 150 to 250 milligrams of lithium within this 120 grams of salt. And so this is a part that already is high enough to be extracted on a commercial level. And Vulcan started with buying the power plant in Insheim in 2022 and getting permission to operate also at the power plant in Landau to do the first lab test, field test to extract the lithium from the brine itself. And within the last 3 years, we constructed live-scale demonstrators, or really on the level of industrial production already. Last year in November, we had the honor in Höchst in Frankfurt here to inaugurate our lithium electrolysis plant. We had the Hessian Minister of Economy for the inauguration of our plant. And before Christmas last year, we already produced the first battery-grade lithium completely without any carbon emissions, if you look at the entire value chain, within Germany, within Central Europe. So if you look at the general lithium demand on the one hand side, meaning the industrialized countries where the cars are produced, China, Central Europe, USA, this is really the first time where the raw material itself was produced within Europe. And we are now in the process of scaling up this entire process to a level where we aim to have 24,000 tons of lithium produced from our assets in the next 5 years. So hopefully we'll start production within 2028 on a commercial level. At the moment, we are in the final processes of getting the equity and debt in hand, because the project that we'll build will go up to a scale which has not been developed in the Upper Rheingraben so far. It has been developed around the area of Munich so far, where more than 30 geothermal projects for heat provision mainly, but also electricity production, are already operating. We now want to bring this on the same level in the area in Landau and Insheim, and are also working with other areas, with other partners in our license fields that we have established in the Upper Rheingraben in the last 3 years as well. So we have licenses from Frankfurt over Mannheim, Ludwigshafen, down to Landau-Insheim, and even down to Bühl and Baden-Baden as our southernmost licenses. And we also started cooperations last year with one of the biggest energy consumer in Germany and one of the biggest also industrial complex in Central Europe, which is the BASF complex in Ludwigshafen. We just completed 2 weeks ago the first step of developing a geothermal project to deliver heat and at a later stage also produce lithium in the BASF premises in Ludwigshafen on a level to achieve about 2 terawatts of thermal energy for the process heat requirements the BASF site there needs. So we will be kind of the first solution also for renewable energies to decarbonize this industrial complex. As we reach the full scale of this development, we will provide about 20 to 25% of the energy demand of BASF at Ludwigshafen itself. Meanwhile, for example, we also work on urban heat provision. We are very close to publicly announce the first drilling location for the city of Mannheim itself, where we already have a contract with the MVV, the local energy company and owner of the district heating network, where we also want to go into the area of about 250 to 350 gigawatt hours of heat produced to provide also about 15 to 20% of the energy demand of this district heating network for the city of Mannheim, helping them to decarbonize their heat provision of the entire city. A similar goal as the area of Munich already has established. They, where we are not included, also are the ones who hope to achieve first a full renewable heat provision for a bigger German city. Yeah, so thanks from my side. I hand over back to you.
And now let's continue with Thomas Weiss from TÜV Süd / Evity. He is electrical engineer, when my research is correctly, and he will talk about hydrogen and the ramp up of the hydrogen system. Hearty welcome.
Thank you very much. So I think, as Professor Birkner already said, I will talk a bit about hydrogen. And I think if you can summarize the hydrogen economy in the last 5 years with one sentence, it would be like everyone is excited until they have to pay. So I think this is a quite good summary of the hydrogen economy. And to give you a short idea of what I want to talk about is with Evity and TÜV Süd, we accompanied in the last 5 years a lot of projects around the globe, from a first idea until or through even the FID gate, so until the final investment decision on the one side, so the project developers, but on the other side also, we did a lot of due diligences, so due diligence, plural, from a technical side, but also commercial side. And there's a few findings I wanted to share with you. There's mainly 3 findings that we have, why a lot of projects didn't reach FID, or why projects got through the FID and reached a bankable stage. So the one, I think everyone talked about it already today, is partnering. Partnering is key on a national level, but also international level. We heard about the projects locally, so it's public-private partnerships between energy agencies and local utilities, for example, between different partners to create local ecosystems. But because we have to admit, the international scale of the market is not yet there. But we're getting there. We're going to talk about European hydrogen backbone later, but this is something that's going to start now. So the local ecosystems on the one side, but also international ecosystems with, for example, offtake agreements like we have between Saudi Arabia, UAE, and, for example, Japan and Korea, where we as Europeans missed the opportunity to be the offtaker because it took too long for us to create a fixed regulation to import the green hydrogen or low carbon hydrogen. So this leads me also to the second point, and the second important point is I think there's 3 points that were crucial for reaching a bankable project. It was a robust supply chain. A lot of projects didn't calculate, for example, just the delivery times of transformers. I think we have a few utilities here delivery times of large transformers is 2 to 3 years sometimes. And then even electrolyzers, no binding agreements. And of course, all the construction work, which will need to be done. So this also takes a lot of time and was often not calculated correctly or included correctly in the business case. Second thing is guarantees of origin, of course, important thing. Without guarantees of origin and the certification of your hydrogen, no one's going to pay the premium at the end. The third thing is qualified staff. It's also something that is not talked about enough, in my opinion, especially large-scale projects. When we talk about a gigawatt project to operate it, it takes a few people. And you need to train them, you need to qualify them. Although hydrogen is nothing new, it's still an explosive gas with some risks that are absolutely manageable, but you need trained staff to do it. At the end, not only to plan it, because I think we have a lot of good engineers that can plan it, that can calculate it on the one side, but operating it is something different. And last point in this case is then the missing regulation codes and standard is a third point that creates uncertainty on the market. So my first 2 years at TÜV Süd, where I was globally responsible for the hydrogen business, I think probably 80% of my conversations turned around the guarantees of origin. So what is needed for my hydrogen and for the project that I have to be certified as green hydrogen and be compliant with the European requirements? And the only thing I could always answer was, it depends. And it depended quite a long time on the discussions around the Delegated Act, around RED II and now RED III. And we now finally have a certification scheme, for example, certified, it's recognized by the European Commission as RFNBO conform. However, a lot of deals already have been made, especially the one between the Middle East and, for example, our the Asian countries like Korea and Japan. So we have to take up or catch up on, for example, these contracts. And the second point is now we're starting the same discussion again around low carbon hydrogen, like blue hydrogen, for example, or blue ammonia derivatives. I'm always including derivatives in when I talk about hydrogen. And I think the discussion starts at new, because we have to admit green hydrogen alone won't solve our problems, at least in the midterm. So we need to source all the hydrogen we can get as long as it's low carbon. I think this is something that we also need to include in our regulations. So they started, again, the discussion. I think also the German government accepted it at one point, but there's still a lot to do. And I think we have to be a bit faster than we've been for the RFNBO. But this on the one side, so I don't want to be too critical, because there's also a lot of positive things that happened during the last few years. If you take just a look at the numbers of the announced projects globally. No, we started in 2020, I think, with $70 billion of announced projects globally. We are now at almost 700. And you can always say, okay, announcing a project, it's easy, because you only need a bit of a business case, a PowerPoint, and a press release, and then you count it. However, also, if we count the projects that reached final investment decision, where the capital is committed, it's even the increase of projects in the globe, in the CAGR, is even higher than only the announced project. So we are now at, I think, over 70 billion, 73 billion, I think, in committed capital in end of 2024. So this is a large number, and I think, it's a positive sign for the next few years to look at the hydrogen business and to invest in it. Thank you.
We approach the fourth speaker. It is not Tamra Turna, it's Tamer Turna. So his name is unfortunately misspelled, but I know that he is very, very tolerant. So please accept my apologies. He's Director of Business Development at Bloom Energy, and he will talk to us also for about 5 minutes about fuel cells, maybe electrolyzers, we will see. And then we start with our panel session and discussion Q&As. So, Tamer, welcome.
Thank you very much. Professor Birkner already introduced me, so I can just switch to the introduction of Bloom Energy. Well, Bloom Energy is a New York Stock Exchange listed company active in producing fuel cell-based power generation units and systems and power stations. And since 3 years, we're also producing electrolyzers with the same technology. And with that, I just would like to use this card. This is a one-on-one size fuel cell that we produce. You see on the anode side, the green part, this is the fuel processing portion of it. And then on the cathode side, the minus poled part, you see the part which is processing the air, which we are using for kind of sourcing the oxygen ions. Now, this fuel cell is a ceramic technology, high temperature type of a fuel cell. And you see here the white part. This is the electrolyte, which is kind of a membrane, which uses to allow to get through from the anode the oxygen ions to the, from the cathode, the oxygen ions to the anode, where then the electrochemical process will take place entirely and generate electricity. Now, this is again one-on-one, the shape, and this produces 30 kilowatts. So everybody knows from their lamps at home that how much kind of capacity or power is 30 kilowatt. We pile 33 of these. We produce one stack, which is 1 kilowatt. We pile 8 stacks and build a column. We use 8 columns in a circle, and we build our reactor, which we name Hotbox. It's a 65 kilowatt reactor that we produce, and it has a shape in form of a box, like you would have at your houses, the refrigeration kind of modules or refrigerators that you would have. These 65 kilowatt fuel cell-based power generators, we kind of scale up to megawatts and gigawatts. And it might kind of sound strange. Yes, the 65 kilowatt modules are in competition with gas combined cycles up to the gigawatt range. And why is that? Because this cell technology has an electrical efficiency as per ASME metering or standard 65%, simple cycle. On a unit base, in Ferrari, where we had our first reference in Maranello, we measured 63.7%. So these are world records in the fuel cell business in general, globally. And having said that, we do guarantee 60% during commissioning, and lifetime, we do guarantee 54%. That's important. Now I'm coming to our business model, business case kind of. We are the only company that is providing efficiency guarantees lifetime and energy production guarantees lifetime. And we would pay so-called compensation fees, penalties in the old terms, if we do not achieve those. So with us, especially data centers all over the world, which are facing a very important struggle in having access to sustainable power, have the possibility to substitute by one-on-one the grid. Having said that, we are not in competition with the grid. Our price, for sure, generation price, will be slightly higher than the national grids of this world, but we are very close to those. And in fact, we are partners to the grids, because the power transmission and power distribution grids are facing a challenge in providing sustainable and on-time power to their investors or customers, like data centers or any other type of an application which would have a kind of a time to power problem. Now, this is about the power. Now, let's come to the topic of delivery terms. We have 2 gigawatt size, annually gigawatt size manufacturing plants, one in Fremont in California, the other one in Delaware. So delivering capacities is not a problem for us. Within 3 to maximum 12 months, we can deliver any capacity a typical consumer would require. Having said that, this cell, as a byproduct, produces also useful heat, air molecules, and because the heat is in form of air molecules, this technology is exempted from the German BImSchV and BImSchG permitting processes. And with that, I have kind of filled my time. Thank you very much.
Thank you very much. Now we have a bit of time for Q&As, and I ask the 4 speakers to join me here on stage. And the microphones should work. At least I was told that they work. Yes. So we did a proof of concept. That's good. May I just ask with some questions to you? Let's start with Matthias Balzer. So you explained the Danish example to us, which is a great example. Can you maybe repeat or focus a bit more on what can we learn from Denmark? What could be the recommendations for Germany, which is far behind Denmark when it comes to the transformation of the heat system? What are goes and what are no-goes when it comes to Denmark or the transformation from Denmark to Germany? And which recommendations concerning changes in Germany do you have in order to speed up the transformation in the heat sector?
Yeah, a great point. So I think it's mainly about consens and consistency. I think those are the key factors. That's what I try to point out quite at the beginning of my little introduction, is the consens and also, the reliability of the will of the political side to actually follow their path and not throw everything around every 4 or 5 years. I think those are the most important things. I mean, there's a lot of technologies, there's a lot of circumstances everywhere that we need to take into account when we think about the heat transition. Every space is going to be different. Even within countries, there's going to be different circumstances all around. But I think that the knowledge to find the right technology and the right solution for every condition is there. We need to really stick to a vision that we have and need to continue building on that vision. I think that is the most important part from my point of view. And I think from a technological side as well, we can also see that other countries are far ahead in terms of technology, not only in terms of hardware, valves, pumps, etc., pp, but also in terms of software, right? So the district heating systems in Denmark, and there are around about 400 suppliers in that little country of Denmark that provide district energy. They also have software solutions in place. They also communicate with buildings within their communities to actually have a good agreement between heat demand and heat supply, all of those kind of things that are not hardware based but kind of KI or AI based are critical to really have a very good efficiency of the system. And the last thing I would really push for is heat recovery or waste heat reusage. We are blowing very much energy into the air every day. It's a kind of free energy. I know it's not always easy to find somebody who needs that energy at that temperature, at that space, but we need to kind of think in that way that we really develop ecosystems where wasted energy can be recovered and reused for good. That in short.
Yeah, thank you very much. It really underlines my statement at the beginning that it's about technology and more. And you clearly confirmed that the attitude, the vision, the willingness, and to act is very important, which brings us back to Mr. Schriefer from EAM, who also said, let's do it. Vulcan Energy, it's a great approach, what you are doing. I have 2 questions. The first one is lithium. I would like to talk about another element. It's carbon. I learned that carbon powder, there is 1,000 different types, even if the chemical substance is always the same, but the consistency is very, very different. Does something similar also exist when it comes to lithium, or is lithium just, so to say, one, I think it's lithium oxide to be more precise, is it, so to say, one a state and it doesn't matter where it comes from? Or do you have a specific lithium? What do you gain? So is it a commodity or something special? So this would be the one thing. And the other thing is when it comes to the heat, you drill holes and then you have a source with a really high power of heat, and now you have to distribute it. So this means you have to build pipelines in order to transport it to whatever sites, to villages, to towns. And so whatever you do, also drilling your holes, has a big impact on the region. How do you integrate the population so that they don't have this typical German Angst? How can you integrate them and how can they profit from your activities? So first, quality of lithium, and second, how do you integrate the people?
Yeah, so thanks for this interesting question. I think these are really some key questions that we always deal with as well. So for lithium, it's mainly, it doesn't matter where the lithium comes from. It's rather the kind of lithium that is used for the battery itself. So normally in the battery market, it's either lithium carbonate that is produced or lithium monohydrate. We choose the direction of lithium monohydrate, which is used in still most of the standard car batteries, which are our main market anyways. And then of course it's I'm just missing the English word. It's the degree of cleanliness. So it really needs to be 99 point something % of pure lithium monohydrate that is needed. So this is really for us the most important step after taking our demonstration plant into operation. It was the first 4 to 6 weeks to reach this refinement stage and actually have a product which is fit to work in batteries which have a long lifetime and long duration and can be charged and recharged several times over. Yeah, and the other topic is really a quite important topic, not only concerning the public acceptance, but also cost-wise. Of course, I think we know also in Denmark that the construction of district heating networks is quite a costly and long-term task. Though this is where we always rely on strong partners. So for our first customer, the city of Landau, they kind of went with us through a process of more than 4 to 5 years of political engineering, political discussion. They were in the entire city completely against geothermal energy because they had made some bad experiences in the past. In 2009, we had a small induced seismic event, so meaning a small earthquake, which, raised actually the German Angst of these kind of projects actually. And it took us with our power plant that we are operating in Insheim, more than 4 years to convince, together with the mining authority, together with the political stakeholder, also the community, that this kind of energy can be managed in a safe and sustainable way. As I said, 12 years of operation in Insheim, not one incident which was critical at all. And as part of our project, we built the pipelines from all of our well sites. So currently we are planning 5 well sites. One is constructed already. We just erected the drill rig on the first well site. And all of these well sites are connected with each other and are connected to the district heating network of Landau. So it's more than 16 kilometers of 4 pipeline systems that we need there. It's a total invest of 220 million that we just need for this part. And the city of Landau itself is looking at another investment of about 250 to 300 million just to construct the district heating network. But with the rather low energy prices that we can provide, since most of our revenues come from the lithium production, we can already provide energy at prices which are lower than the current gas price. And that gives them the freedom and the long-term planning they need to be able to do such investments as well.
Thank you very much. My question to Thomas Weiss is very short. You talked a lot about the backbone grid. You also talked about the distribution grid. But where does the hydrogen come from? It's nice to have a grid.
Yeah, it's a pretty good question at the end. So I think that, what I think, like the hydrogen is going to come from a few different sources. It's mainly, in my opinion, like Spain, like the southern European countries, especially Spain in this case. And then hopefully, because I mean the first MOUs are signed, for the grid connections also to Morocco, Tunisia, and Egypt. Although Egypt, I doubt a bit that the construction's gonna go on quickly, but I count a lot of Morocco and Tunisia, and hopefully then also Norway, and like a third option that is hopefully gonna come in a few years when there's peace, or the Ukraine, because there's a huge potential in Ukraine. There's a pipeline connection that is already there. And I think if we can leverage this potential, it could be a win-win situation for both sides.
So we have to hope that the others don't need the energy for themselves.
I mean, at the end, it's always who pays the most. And when you take a look at in my opinion, it's never the question how much hydrogen costs. At the end, it's the question what's the cost of the alternative.
Yeah.
And especially when you take it the decarbonization strategies that we made for industries, you always have three options. I mean, it's electrification, hydrogen, or CCS. And electrification is always a bit also in the other two. But then at the end, it depends mainly on the cost for transport. And as long as you have to transport the CO2 away with a trailer or the hydrogen to the customer with a trailer, it's not competitive at all. However, on the electrification side, so if you have a high connected power, connection fees are high. Grid fees are going to go up, like they ramped up enormously in the last few years. So if the grid fee is going up like this, it's going to be extremely expensive also to electrify a lot of these processes. So I think also the cost of the alternative is going up year by year. And if we manage to get a pipeline grid where you can transport hydrogen from areas where we can produce it cheaply to the customers, it's a viable option. The same as CCS. So a lot of cases, for example, we had now 2 customers in the glass industry, where if a CO2 grid is going to be built, which I think it's going to be, because the grid operator is talking about investment decision at the moment, then even CCS is a valuable option, and even cheaper than electrification and hydrogen.
Okay, so we will have a very diverse future. Thank you. My last question goes to Tama Turner. Can you elaborate a bit on the USPs of your solution? So two sub-questions. Why should I buy your fuel cell and not another one? And why shall I buy a fuel cell at all and not go, for example, for a CHP or another solution? And maybe you also can give us some insights what you're going to do with the heat. In order to support you a bit, the best gas turbine I know has a efficiency of about 60%, and you are even beyond this. So the efficiency for electricity is extremely high. Maybe this is already the first USP.
Right. Well, thank you for the question. Now, let me start with your last question. 60%, that's the H-class gas turbines, for those. That's combined cycle. So the 60-65 that I kind of addressed, that is simple cycle.
Yeah.
So we still have roughly 30-35% to go with our exhaust air. Again, I call it exhaust air. We do not have exhaust gas molecules, because all the molecules that are kind of anticipated to the atmosphere from the anode and the cathode of this cell are air molecules. So there is no NOx, zero NOx, nearly zero NOx. So we still have exergetically a very high temperature exhaust air that we can use to generate additional sources, like you can do waste heat recovery. You can go up to 95% in total efficiency. You can run a direct hot air-driven organic Rankine cycle to boost the electricity, or you run a hot water-driven organic Rankine cycle, which is used in the geothermal industry since decades. Or you run an absorption chiller, etc. So there are many add-on technologies which then make the viability even better. When it comes to comparing why you should use the fuel cell of Bloom compared to conventional gas engines and gas turbines, it's the leverage cost of electricity. We do have the lowest leverage cost of electricity if all these energy sources are used. One more important topic, which Thomas just kind of touched to, is carbon capture and utilization. So this cell has an ultimate result that the molecules are already split in the process. So on one side we have CO2, on the other side we have untouched nitrogen. So you only need on the anode side to chill the exhaust air and get rid of the water that condensates, then you have CO2 in a E290 kind of food and beverage context of quality. You can sell that to methanol industry, to the aviation fuel production industry, and of course to food and beverage. Yeah.
Thank you very much. That is a multi-purpose machine. We have some 5 minutes left, maybe 4. So if there are any additional questions from your side, we can pick some of them and try to answer them very, very briefly. And I would appreciate if your questions also would be short. Please. It was the gentleman behind you.
You hear me?
Sorry. And then we
yes, thank you very much. I think we're on the same line. To the Mr. Turner from Bloom Energy. You have quite a lot of projects in the US with Walmart, with Intel, I think, in the data center. What kind of feedstock you use? Is it hydrogen? Is it natural gas reformed to hydrogen, or is it natural gas and with, I think now CO2 emissions?
Yeah, well,
may I ask you, with respect to time, that we collect a few questions, then we answer. So please keep it in mind. Here was another question. Wait for the microphone that everybody can hear you.
For Mr. Baer, you said that the brine solution that you get from a geothermal is a lot of salt. Do you also plan to use the sodium for batteries at some point, or is that not an...
You keep it in mind. Some more questions? Here is one more, and then we try to answer.
Yeah, maybe a local question from Wiesbaden. I know there's also a lot of heat energy from the earth. There's the Kochbrunnen. It's a hot water source. Maybe is there a way to get Wiesbaden local heat grid from the heat source from the earth?
Okay, so we have one question to Tamar Turner and one to Christian Beer. So please try to give the answer.
Right. Well, thank you for the question. We serve the majority of the known cloud industries in the US, but also globally. And the main fuel still is natural gas, so methane or biogas. As we have also several biogas and biomethane references. And well, the data centers, of course, use them for kind of cope with their power needs. In the US, you have 38 hours of power cuts. In Germany, the average is only 12.6 minutes, and Hessen has the best best grid with 3 minutes only. Yeah. So.
Thank you. And now the...
Maybe one very quick question would be no at the moment, but we have that in mind for the future potentially. Sodium chloride is the main constituent within our thermal brine. So from the 120 gram per liter, it would be about 80 gram per liter sodium chloride, like Kochsalz, which could be used, but not in scope at the moment. And the other question concerning Wiesbaden, there has been developments by the ESWE, the energy provider of the city of Wiesbaden, already about 10 years ago, to develop a geothermal project. I think that got stuck both before FID and due to permitting issues. So I think the potential is quite good and it could be used, but there has to be somebody stepping up and saying, let's do it.
So he has to be triggered.
Maybe.
So thank you very much. Let's give the speakers a hearty round of applause. Thank you very much. If there are any further questions, please address it directly to the speakers. They should be around here. And I will now close this session.